Hi, my name's John and welcome to another Sunday night nightcap. To say it's cold outside will be a slight understatement. We've had severe frosts all week. I haven't spent as much time in the shop as I would like to have, but I have gotten one or two bits and pieces done. I'll show what I've been doing this week. Last night I put a video up, a Christmas giveaway. It's for an arc welding kit that was kindly given to me by one of my channel sponsors, Rob from Extreme Plasma. I'm going to put a link in the introduction box of this video so you can have a look and see what you think. It is for UK only, so UK mainland, free postage only. If you want to enter from abroad, please enter, but you'll have to pay the postage to get it all shipped abroad. I've got a couple of these little, they're actually locking dowels or locking bolts off an old woodworking machine. The lad obviously can't get them, he can't identify the thread, and that one there is quite badly chewed up. It looks like E1F, but I'm not 100% sure. We'll measure the outside diameter. It's near enough 5/16 of an inch. So it's either E1F or BSF. E1F is 24 TPI, which that isn't, and BSF is 22, which that is. I'll bring it a little bit closer at the camera so you can see that. Right, that's 22 TPI is a good fit, and 24 doesn't fit, so no, the thread is 5/16 BSF. I've got a 5/16 BSF die nut, I'm sure I have. Right, I found a piece of suitable material. Whatever that is, it's not mild steel, that's decent stuff that. Anyway, we'll persevere with it. Anyway, we want 2.6 off there. This is good stuff, this. This machine a little bit like stainless, but it's actually magnetic. You can get magnetic stainless, of course. Don't do that size there, which is the diameter for the thread. All we'll do with 0 the vernier, and we'll get a direct reading off there. How much we want of it? 1.5 mil. Right, some threads to go on there now. Yes, that's severely hard, that. We've got a 5/16 die nut here, a good one, so hopefully that'll put some nice threads on for us. But like I say, the material certainly seems to be very hard. See what happens. It seems to be doing alright. Going on anyway. enough pressure on the tail sock just to keep the die square. I think we're just about there for thread depth now. Let's put a nice clean sharp thread on there. A little bit of advice when you're doing this is take the tool out of the tool first, because you'll cut your hand on it. That tool really wants to take the back of your hand off, so take it out. And then it can't get you. Right, that's a nice thread, I'm happy with that. And the thread's the same depth as that one. There's a little recess machined in there. I better put it in, I'm not quite sure what goes in there, but I'm going to put it in and then part it off, and then we've got the slot to put in. I found a nice little high-speed seal tool which should do the job quite nicely. That looks good. Right, you need parting off the length, turn round, machine the other end, and then put the slot in it. A little bit on just to reface it. This is not nice material at all, this. Not even a little bit nice. Right, so I'll put that piece of bar in a box and call it horrible stuff. Horrible edge of it. Right, we want 1 mil taken off the end. I'm going to make it pretty good, but we might as well make it the same as the original part. Very, very slightly below centre height. Not now, it's not. Right, 1 mil. I could just put that slot in with a hacksaw blade, but it wouldn't really make a very good video. Because I've got a milling machine standing here doing nothing, and some slitting saws, we might as well use them. Collar chuck, that's the wrong one, stupid head. Collar chuck won't damage the threads, ideal for this particular application. Right, face needs fastening down properly, and then we can set things up and machine the little slot in the end. We need to find the centre. We could eyeball it, guess it so to speak, how to get that probably within a thou or so, but what we're going to do is just put a little, I feel like edge or something underneath here, and just work things until it's just starting to bite, and we can do top and bottom exactly the same. In the good old days, or the bad old days when I used to smoke, I would use a cigarette paper for this. What a 1.5 thou feel like gauge will do. It's just nipping it there. So 0 the Z-axis, and then we'll take it underneath. Once again in with a feeler gauge. Bring it down this time, up rather, no down, until it just nips the feeler gauge. Which is there. And we'll half the Z axis. Easy to do, though. Which is there. Lock the Z axis off now. And when I look at it, it's near enough. It's right in the middle, it can't be anything else. Make sure all this is tight. There's a little Allen bolt under there. I'll find the bastard Allen key that fits it. It's just a homemade holder. It has a little bit of wobble on it. It doesn't really make any difference for the application we're using it for. These need to be run slow, very slow. It's basically just a hacksaw blade, so it's going to run as slow as a hacksaw. You slow things right down as slow as we can get on the belts on this milling machine. Now, of course, I've got the inverter so I can speed it up or slow it down to me heart's content, really. Right, a little bit of juice on there. Right, I've got the blade run the wrong direction, which is not the end of the world because I can run this backwards, which will save us having to turn the blade over. Right, so now it's going to cut. It's really only cutting on one part of the blade because it's not central. I should really make another adapter for this size of cutter, but for what I'm going to do, it's going to be okay. Right, this will be the last cut. Looks good. Right, so that's it done. Right, so I'm sure the grader's in the middle. Looks better than a hacksaw slot, nice and parallel. That's the original one. I'm sure I'll be happy at that. I'll run a dye down this one to clean the threads up for him. And you clean them quite nicely.